Welcome everyone to Snorkel Science Talks, a series where we interview thought leaders in AI and discuss themes around making machine learning practical. And today I have the privilege of interviewing Dr. Paroma Varma, my fellow co-founder and friend of many years. Thanks for chatting today, Paroma.
Of course.
Paroma and I go way back. I remember exactly which room we met in the Gates Computer Science building at Stanford, because that's where Chris Ray had his lab lunches, and we both showed up on the same day. And then little did we know, of course, we've been working together for years. But as you know, Paroma, we like to start always by hearing what each guest's path to machine learning was. So let's hear yours. What led you to that fateful day where you first got interested in working with Chris and ultimately on the Snorkel project?
Yeah. So I got my undergrad at Berkeley and I did ECS, so electrical engineering, computer science there. But I was taking classes in both. It's not like I went into undergrad saying machine learning is what I wanted to do. So interestingly, the first lab that I worked at, which was a neuroscience lab with Dr. Knight, the first project that I did there was a machine learning project, and it was being applied to EEG data. So even back then, I was like, oh, this is really cool, but not something, I didn't really connect that the machine learning I was doing there was also something I could have done in my undergrad major. So I actually worked in a computational imaging lab with Professor Laura Waller. And I was really interested in signals. So I kind of stuck to that, did that, and then decided to go to grad school. Also kind of keeping my focus in the imaging and signal processing area. And then I guess once I got to Stanford, I kind of started exploring different areas. So I knew I liked optimization, signal processing. I knew I really enjoyed kind of the practical applications of the theory work that I was doing. And I don't remember, but I learned about Chris's work and ended up at that lunch. And I guess now I'm here. So definitely not a path where I knew exactly, that I wanted to do ML for many years. I was exposed to it early on, didn't make the connection. And then now that I go back and actually read the paper that I was a part of, I said, oh yeah, I understand everything that we did here versus earlier, it was more of a learning experience. But I think I'm really glad that, I ended up making that decision. The lab was great. Chris is great, got to learn so much during that time.
Yeah. Well, I think that winding path, that you described, sort of, meandering our way ultimately to machine learning is so typical, especially in a field that's this young. And I think it's really made for a really rich field where you have so many ML practitioners who have backgrounds in so many different areas, which has just made for this explosion of applications.
Yeah.
That's been really fruitful. Cool. So leading up to that time, of ultimately getting a PhD, at what point along the way would you say that you decided that that's what you wanted to do? That the years dedicated to research was going to be something that you'd be interested in?
Not early on. I would say probably, later in undergrad, maybe my junior or senior year is when I made that decision. I think even when I was doing research, I was kind of doing it because I enjoyed it and I wanted to kind of learn more about different areas. So I didn't think, doing research in undergrad was like a way to get to getting a PhD or, applying for PhDs. But I think once I started talking to Professor Waller about, this is what I'm thinking, this is what I'm interested in. I kind of really like this idea of independent research, and you get to kind of think of new ideas and go really deep into this topic. And I hung out with, grad students while I was an undergrad, and I thought that they were having a ton of fun doing kind of exactly what they wanted to do. So I thought it would be fun to apply for a PhD. So that's where I ended up. I think it was definitely very different than I had imagined it to be when I applied. But I'm glad I did it.
Yeah. Thought it would be fun, she says. Hopefully it ended up being that.
Definitely, definitely.
Yeah, actually, maybe we can elaborate a little bit there. When you think back on your PhD experience, what do you see as sort of the typical day, or what comes to mind, I guess, of what that chapter included?
Yeah, I think when I went in, I used to think that you're kind of a lot of your time is just kind of thinking and brainstorming different ideas. That was kind of my view of what it would be like. But I think that's just because that's what I'd seen and that's the stage I'd seen most of the grad students in. I don't think there was kind of one day I could describe that would be representative of the years in the PhD. I think the only common theme I could find is probably getting coffee every day. For some reason, that's a really strong memory in my mind. But other than that, I think there's sort of like different types of days. I would say, the brainstorming, whiteboarding, discussion part. I think which is really fun. I've definitely done a ton of that in your office, taking over your whiteboard. So I think there's that part. Then once kind of you have an idea, you're coding, you're doing different experiments, and kind of keeping track of what's working, what's not working, and developing your idea there. And then there's the writing aspect, which I will be completely honest. I knew, that was a part of the PhD, but I didn't know exactly what it would be like till I had to do it myself. And I think, writing papers, submitting, thinking about what you're working on, from different perspectives, what the high level idea behind it is. I think that's another part of it. And that, you can't, it's not just like sitting and coding all day, right? It's a very different type of kind of mental space that you have to be in. So I think the PhD is really cool because it like kind of forces you to go through all these different phases and kind of hone your skills in each and every single one. And almost all of these are like applicable, no matter what you're doing, especially for us right here at Snorkel AI. So I think I'm really grateful I went through that experience and got to learn from such amazing people, how to do each of these different things.
Yep, no, completely agreed. Great origin story. So let's move on now to talking about some of your research, both that you completed during the PhD as well as in the time since. So, in the Snorkel ecosystem of research projects, one of the areas that you in particular have specialized in over the years is applying weak supervision to non-text domains, right? Medical images, scene graphs, sequential data, all sorts of exotic and interesting things that go beyond just your typical ImageNet or text corpus. So what were some of the challenges that you faced and ultimately ended up researching and tackling that focus on these types of problems that maybe don't first come to mind when you think of Snorkel?
Yeah, so when I joined lab, I worked on one my first project, I guess, was related to making this process of error analysis a lot easier. So I'll come back to that because that's definitely become really interesting in terms of what we're working on now. But I got really interested in this idea that Snorkel was being applied to text data. People were writing ways of kind of weak supervision where you had labeling functions or these rules that people were using to label their training data. But with text, they had the sort of freedom to use things like parts of speech, regexes, really simple keyword searches, and you could kind of express a lot just with a few lines of code. What I started to do was because I worked with images in the past, I really wanted to apply a similar technique to that domain. And one of the first blockers that I hit was you couldn't really write that many rules over a raw image. So, let's say you had a picture of a person riding a bike and you wanted to see, is there a person riding a bike in this image? How many of them are there? I can't look at the raw pixel values with the RGB colors and write these labeling functions like I could for text. So I would say like kind of one of the first ideas that we had to work through was this concept of what we call domain-specific primitives. So these are essentially these interpretable characteristics or building blocks of the data that you're working with so that you can then start writing rules like you would for text. I think with image data, video data, basically a lot of the non-text data, we could take advantage of a lot of the work that had been done in the past, whether it's signal processing pipelines, whether it's other ML pipelines. You could kind of take their output because they're interpretable and write labeling functions over that. So going back to this person riding a bike example, you could pass all your images through an object detector, get bounding boxes for, hey, there's, one person here, one bike here, and then write some relational rules over that. Like, is the person over the bike or not? Are there kind of sizes and similar or not? Is one in the background, one in the foreground, and kind of use that to label your data. So this made for, first of all, I was really excited that, something that seemed really crazy initially of like, how do we transfer this to different domains was indeed possible once we had a good set of primitives to work with. And I think the other great thing was with this type of research, I really got to I got the chance to kind of collaborate with a ton of people, both at Stanford and outside, and getting the type of feedback that you get from practical applications and using that to kind of hone your research, really feeling the pain points that you do when you're trying to work on a practical application. I think that was really inspiring for the remainder of my PhD as well.
Yeah, no, as you know, and you and I have discussed, I think this whole regime of the intermediate levels for weak supervision, the primitives and building blocks that you'll sort of add on top that make
Exactly.
it easier for humans to interact in different intuitive ways is super interesting. And then just green field, right, wide open for all sorts of extra research and developments over the years. Awesome. Well, another project that was very interesting, less focused around new modalities and more on the technique itself, I'd say, is your project called Snuba, which essentially automates some amount of the weak supervision using a small labeled subset of the data. How optimistic do you feel about the promise of that line of work in the long term? Is it possible to automate some of that subject matter expertise, just by using the outputs of maybe there a small amount of labeling time?
Yeah, so I think with the Snuba project, that was one of the projects where, I wanted to work on it because I was feeling some of the pain points. So when I started working on image video data, a lot of the weak supervision rules we were writing were over numerical features and numerical domain specific primitives. What that meant was a lot of times you were kind of guessing and checking different numerical thresholds, which just felt like something that could be automated. And I think my second inspiration actually came from one of your projects when you worked on Babel Label, where you were looking at how we can take natural language explanations and then convert that into weak supervision signal. So this idea, overall of just making it easier and easier for people to kind of encode their knowledge, encode weak supervision for machine learning, just lowering the barrier even more was really exciting. So when I started working on Snuba, I was very focused on, exactly these numerical features. And I think it worked well in that area. Now kind of reflecting back, I would say that it's challenging to replace domain expertise completely. I think an ideal solution is one where you can inject the domain expertise and then automate different parts of this pipeline. I'll go back to my classic, person riding a bike image thing again. So I think you need the domain expertise to tell you like, oh yeah, there's rules in the real world that say the person should be above the bike. How much above, that part can be automated, to kind of come up with the right set of rules. You can think of, there's work been done with using this type of supervision, using knowledge from physics, domain knowledge that maybe radiologists work with a lot of medical imaging data. So I think there's this trade-off where you want to make sure that the human knowledge and domain expertise is still somehow injected into your system, but the part where you're literally like typing, trying, that kind of part gets automated away. And I think it's an interesting balance. And if I could go back and keep working on projects during my PhD, I think that's exactly the type of thing I would like to explore.
Mm-hmm. And all of these projects that we've described so far focus, very much on the supervision side of machine learning.
Right.
let's contrast that with sort of what we're focused on, especially now at Snorkel AI, where there's a bigger emphasis on building, end-to-end
Right.
AI, the full pipeline, complete applications, and not just a component. So, what's motivated that shift, and what opportunities come from tackling this from the platform level rather than just as maybe a labeling component?
Yeah, and I want to ask you this question back after I'm done. But I think one of the most amazing things about what we're building at Snorkel now is the fact that Snorkel Flow, which is the commercial platform, is this end-to-end way of iteratively developing your machine learning pipelines. I think a lot of times when you do research also, you never just train a model and then you're done. You're happy with your result, right? Especially in the real world when you're working with models that say are deployed, your training data might be changing. You might see some differences in how your model is performing in the real world. So it's kind of this thing that you always have to keep monitoring and analyzing, and keep going back to refine. And I think one of the biggest things that Snorkel Flow does is make this error analysis, monitoring, and analysis process a lot more automated and kind of everything within one area. And that I think is the real power of what we're building now. Training data is still kind of that first blocker that we hit. And, we'd identified this while we were working at Stanford, and we still have that. But the fact that now we kind of have the rest of the pipeline within the platform as well, what that means is now when you're fixing your model or you see something wrong with your model, with the guided error analysis process, you know exactly where to look next. Like, do you go back to your weak supervision signals? Do you go back to your model? Is it something else? While you're iterating, even on your weak supervision signals, you have a good sense of how is it going to affect my end model? Are there specific subsets of data I care more about? Should I pay more attention to them? So I think that end-to-end aspect of it makes the error analysis much easier, which really supports the fact that building these ML pipelines is truly an iterative process and not really one and done.
Yeah, no, totally agreed there. In my mind too, I think just the end goal going into a problem you want to solve with machine learning is never the training set. It's the final quality, the final, the full machine, I guess. And so I think of it basically as, observing as people use Snorkel in larger components, look for the desire paths, like look for the ground that's being tread over and over again to make it work,
Right,
and
right.
and then we've paved kind of over those places to put the whole system on rails and enforce best practices and sort of transfer some of the learnings that we had over the years around how to really make this, sing in a good way. So
Yeah, and
awesome.
I think one thing that you reminded me of when you said, have like looking at how people are kind of going through this process. A lot of the work that we were doing, especially with image data, was with radiologists, and these are subject matter experts. They know exactly what's going on with their data, and I was kind of trying to look at the same problem from more of like a data science perspective or machine learning perspective. And it was really fun to be able to collaborate with people who knew so deeply about their task, with someone who kind of lived in the pipeline aspect of it. And I think we've done the same thing with Snorkel Flow, right? It's just this great tool for people from different backgrounds, whether it's a data scientist, a subject matter expert, a machine learning engineer, to sort of come together and tackle that task. And we have the UI, which is really exciting. I would say even as a data scientist and machine learning engineer, I love the UI. Of course, if the SDK is there, the API is there if you want to go that way. And I think that sort of flexibility of how you want to work within Snorkel Flow, the ability for people of various backgrounds to come in and work on that same problem, just making an amazing tool for people to really get these practical ML pipelines out the door.
Excellent. Well, before we wrap up, one last area I'd like to hit is just looking at where we are today, taking this technology and applying it at a company at Snorkel AI. Would love to hear what is your favorite part about working in this environment, working at Snorkel.
I would have to say the team. I think the team that we work with at Snorkel is just it's full of these amazing individuals, and I know it sounds cheesy, but it's true. I do get to learn something new every single day. And I think it's just been so much fun watching the team grow, getting to know different people, and I think honestly, like even with remote work now, we've we've done, I think, a great job in making sure that we stay a tight knit group. And the fact that I like wake up in the morning and then we're talking to people about different things. We hang out during stand up. We have game nights. It's just so much fun. I don't have any other word to describe it. And the fact that everyone is so passionate about what they're building, I think that just kind of renews the passion of for me also in terms of what we're working on. So that's really been an amazing experience so far, and I'm really really grateful about that.
I completely agree with your assessment of some of the highlights here. So much fun is also how I would describe it. Just like the PhD. Great. So as we wrap up, how can the audience find you? What social media or website or other places would you recommend?
I have a website which I created when I was in grad school. So it's very researchy, and I'm on Twitter. So if you ask my handle, I have no idea. But if you search my name, I think it's unique enough that you'll find it.
Great, and we can post those as well, with the link. So
Great.
I think that does it for us. Thanks so much, Paroma, and I'll see you in the virtual office.
Of course. It was great doing this. Thanks, Braden.
Bye.
Bye.